Hey guys, today's video is going to be on 3.3, which is multi-step equation. It's a mix of what we learned in 3.1 and 3.2. So in 3.1, we learned about solving equations using inverse operations for addition and subtraction. In 3.2, we learned about solving equations using inverse operations for multiplication and division. But what if we're given an equation where we have to do both? Let's check out some examples. So we're asked to solve for x. In the first equation, we have x over 3 plus 6 is equal to 8. Now remember, when we're supposed to solve for x, that means we want to get x on its own. We want to isolate it. So we have to look at everything that's happening to it and then do the inverse operations. So the first thing that I notice is x is being added to by 6. And from 3.1, we learned that the inverse operation of adding 6 was subtracting 6. So we'll subtract 6. What you do to one side of the equation, you have to do the other. So we get x over 3, our 6's cancel out, and then we have 8 minus 6, which is 2. Now the other thing that's happening to x is it's being divided by 3. And remember, the inverse operation for dividing is multiplying, so we'll have to multiply by 3. Our 3's cancel on the left, and we're just left with x is equal to 2 times 3, which is 6. There we go. So you guys try to do the other ones on your own, see if you can get through them, and then we'll come back and you can watch me do them myself. So for b, we have 7x minus 3x minus 8 is equal to 24. So for this one, we're going to have to do a little bit of simplifying first. If you notice, 7x and 3x are like terms because they both have a variable, x. So let's combine those first and then work from there. So we have 7x minus 3x. So we combine our coefficients. So we have 7 minus 3, which would just be 4x. So over minus 8 is 24. Now it kind of looks like the example A. So we have x being subtracted by 8 and multiplied by 4. So we have to do inverse operations. The opposite of subtracting 8 would be to add 8. We have to do that to both sides. So our 8's cancel. We get 4x is 24 plus 8, which would be 32. And then we have 4 being multiplied to x, so we have to do the opposite. So we divide by 4. So we have x, since our 4's cancel, is equal to 32 divided by 4, which is 8. For c, we have 4x minus 3 times x minus 2 is equal to 21. Now again, we have to do a little bit of simplifying with this one before we can start to solve for x. So we have a 3 being multiplied to these parentheses. So we have to distribute that 3 in. And by distribute, I mean we have to multiply x by negative 3, and we have to multiply negative 2 by negative 3. So we have 4x, negative 3 times x will give us negative 3x, and negative 3 times negative 2, well, that's a negative times a negative, so we'll have positive 6 is equal to 21. And now again, we have like terms of 4x and negative 3x, so we can combine those. 4 minus 3 is just 1, so we just have 1x plus 6 is equal to 21. Well, 1x we can just write as x. So we have x plus 6 is 21. And then we just have that 6 left over, so the opposite of adding 6 is going to be subtracting 6. We have to do it to both sides. So we get x is 21 minus 6, which would just be 15. And there we go. For the last one, we have 2x over 3 plus 1 is equal to 3. Again, we have to do inverse operations. So we have plus 1. Inverse operation of adding 1 is going to be to subtract 1. We have to do that to both sides. So we have 2x over 3 is equal to 3 minus 1, which is 2. And now remember from 3.2, when we have x being multiplied by a fraction, so 2/3, we have to multiply by the reciprocal. So we take that coefficient of 2/3, we flip it, and we multiply it. So 2 over 3, if we flip that, is going to be 3 over 2, and then we multiply it. And what we do to one side of the equation, we do to the other. So we'll multiply this side by 3 over 2 as well. So our 2's cancel, our 3's cancel, we just have x left over, and then we have, technically this is 2 over 1 times 3 over 2, and you can notice that our 2's cancel here as well, since we have 2 in the numerator and a 2 in the denominator, and then we're just left with 3 over 1, which we can just write as 3. And that's how we can combine our knowledge of inverse operations for addition, subtraction, multiplication, and division. In the next video, we'll be looking at 3.4, which will look at when we have variables on both sides of our equation.